create a function that is based on f of x. Nothing is removed from f of x. So f of x is inside a new function. Let's call it g of x. So let's create g of x that has f of x in it. You don't have to write f of x here, but I just wanted to emphasize, which is x squared plus 1 times x plus 1 for x anything but, what should I write? For x anything but
1.
Excellent. And now I have to establish something else. So g has f in it, but it has to have an additional value that fills in that gap, the gap of x equals 1. But the question is, what number do I need here? And I know you have the answer. Let me plug in my system here. Because I think it needs more power. Okay, it's in. Okay, so what do you think should go in here? Anyone? Can anyone guess?
Would it be x minus 1?
No? It's right there on the paper. You're looking at it. Say it again. I don't know if you said 4, but I wanted to hear 4.
I did say 4.
Did you say 4?
Yes.
Excellent. Of course. Look at the limits. That's why I put them there. If the limit from the left and limit from the right is 4, the function value has to be 4. If it's not 4, g of x will not be continuous everywhere. That's why I wrote them there. Does it make sense? So what do you conclude about this? What can you say about g of x now? I couldn't hear you. Everywhere. And when we say that, we say on all real numbers. We made it continuous. See, if you plug in 1 here, you get 4. But you're not allowed to plug in 1 here. How come? Because the function started like this, and it's not defined in 1. So if you want, you just write the original function, not the simplified one. That's also correct. So you can write, if this is better for you, you can write, what was it, x to the 4th minus 1 over x minus 1 for x not equal 1, and 4 for x equals 1. That's another way of presenting the same function. Or that. One or the other, both are the same. Very good. Okay, let's look at a problem with a parameter. And let's see what that means. Let's say we're given this function, 47. Any questions on this, please? Anything? Don't let me move on if you have questions, please. So we have f of x, and it's given to us as a piecewise defined function, cx squared plus 2x for x less than 2, and x cubed minus cx for x greater than or equal to 2. So it's a piecewise defined function, and let's read the requirements or the question. For what value of the constant c, or parameter c, is the function f continuous everywhere? So the first thing that I have to write is that these two branches, so remember this is negative infinity to 2, and this one is 2 to infinity. So first thing that I have to write is, and I'm going to write a note because we did not write it before, all polynomial or polynomials are continuous everywhere. So we are never afraid of polynomials. They are continuous everywhere. There is no gap, no jump, no removable discontinuity, no infinite discontinuity. So because of that, cx squared plus 2x and x cubed minus cx are continuous on negative infinity comma 2 comma 2 infinity respectively. Okay, so that's established. But what is my only worry? This is continuous everywhere, not only on negative infinity to 2. This is continuous everywhere, not only on 2 to infinity. But what is my only worry here? What could be the problem? Or a problem? What is the problem that I could run into?
If there's a jump discontinuity too.
Great job. So what do I need to study? Study
The left and right hand limits.
continuity at x equals 2. And the definition is very clear. The limit as x approaches 2 from the left must equal sorry.
Bless you.
Bless you too. I just can't. I always hold it in. Sorry. Must equal f of 2. So please tell me the limit from the left of what and the limit from the right of what. And what should I put here and here?
The limit of 2 from the left is equal to cx squared plus 2x.
This is too light of a color. This is not good. And of course, that's from the right, which is x cubed minus cx. Well done. And now I would like you to tell me what does this equal to, what does this equal to, and what does this equal to. Remember, every time we calculate limits, the first thing we need to do, we have to
Plug in.
yes. So please, very good, awesome. In this case, a is 2. So what do we get? My cheap markers are drying out. But I am waiting for you to tell me.
4.
Say it again.
4c plus 4.
Very good. This must equal. Great job.
Minus 2c.
And must equal. And now be careful where you plug it in. It doesn't really matter, to tell you the truth. But where do I plug in 2? Here or here? For f of 2. Top or
You
bottom?
would do the bottom one because it's inclusive.
Excellent. Great job. So there is no point in writing it again, but I will because I want you to see where it's coming from. This is coming from here and this is coming from here. but I cannot have a triple equation, right? So these are two are the same. I'm going to add 2c, so I get 6c. I'm going to subtract 4, I get 4. So c is 2/3, 4 divided by 6. And now I guarantee that the following function is continuous everywhere. And I will plug in 2/3. 2/3 x squared plus 2x less than 2, and x cubed minus 2/3 x for x greater than or equal to 2, guaranteed. We made it happen by setting the left, the right, and the function value equal to each other. And we say that now this function, continuous, guaranteed, on negative infinity to infinity. Great job. Okay, there are two theorems here, but we are not going to use them till later, so I'm not going to discuss them. It's the swapping of the operators. So I just want to say one thing. I'm not going to go through the theorem now because we're not going to use it for a while. But I'm just going to say this. Swapping operators under, because this is important to say it now, under continuity. If there is no continuity, we are not allowed to swap operators. So, for example, limit of f of g of x when x approaches a. Can anyone guess? We've seen this before. We applied it in limit laws, and I mentioned this very important theorem, but I didn't show it for the general case. So which operators am I swapping then? What should I write? Under conditions of continuity. Everything has to be continuous. What does this equal to, you think? Anyone? I'm swapping the operators. So it's f of the limit of g of x as x approaches a. Swapping the operators. Okay. Yes?
Can you explain how you got c equals 2/3? I just don't see it.
I divide both sides by 6. 4 over 6 is 2 over 3. So what I did, I moved.
6c equals 4.
Oh, so I added 2c to both sides, and I subtracted 4 from both sides. So when I move a term from one side to the other, I change its sign. It was negative on this side, it will be positive on this side. If I
combine, or you solve, like, I didn't realize both sides of that equal sign were part of the same equation.
yes, so that is a little bit confusing. So maybe I should put this in parentheses because we cannot have an equation with two equal symbols. But I was just showing you where they come from. So the equation that we're solving is this. Because this is the same with this. So I'm solving a linear equation, and I have to add 2c to both sides, and I have to subtract 4 from both sides.
Okay, thank you.
Thank you. If you ask questions, you're helping me because I skipped something, I guess, I didn't explain, and you're helping your colleagues. So not just me, you're helping your colleagues because somebody else may have the same question and they may be shy to ask. So please ask any question anytime. Is there anything else? Is there anything else? Okay. We can stop now if you want and work on a little quiz for a few minutes. And then we can continue with 2.6, infinite limit. Or we continue with 2.6. So you want to take a few minutes and work on some problems?
I think we should work on some problems.